Hello, I would like to start by thanking you all for attending our presentation. As mentioned in the publication title, our work is about a platform for remote monitoring. My name is Francisco de Izaguirre, and I'm here representing our research group. My partners are Maite Gil and Marco Rolón, and our mentors Nicolás Pérez and Pablo Monzón. The institution that supports us is Instituto de Ingeniería Eléctrica por Facultad de Ingeniería of the Universidad de la República, Uruguay. Now, what is the problem? When developed or used an AI solution, a large amount of data is needed. In this way, many research groups and economic sectors need measuring systems, and they often do not easily find solutions on the market that solve their problem, or those solutions are not affordable. There is also need for systems that are easy and quickly developed while looking for new solutions at any particular problem. So, what feature might the system have? Reliability and robustness, scalability, new sensors should be adapted easily, remotely and bidirectional data transmission, power autonomy, and weather resistance. In conclusion, we find a necessity for an acquisition platform that can be easily adapted to any desired problem. This platform needs to be reliable and tolerate bad connection signals. It has to be independent of the power supply network and, of course, a friendly user interface. So, let's take a look at our solution. We designed a modular system. This modularity is present in many ways. In the first view, the problem can be divided into two big blocks: an in situ block, the device, and a remote block, the server. This is reasonable. Now, in the in situ device can be separated as three blocks. Two of these are quite intuitive: a power supply block and another related to the acquisition. We decide to add a block that we glue those two and the server. That one will control the internal and external communication and is also responsible for the management of the sensor network. Reclosing the idea, the device can be divided into modules: power supply module, one or more acquisition modules, and the main module. All the in situ modules obtain the power from the same source, and the communication between them is over I2C. This is why we designed a bus with a pinout on a 7-pin connector. Over this bus travel I2C connection, ground, 3.3 volts, 5 volts, and 12 volts. For the remote connection, we decide to use MQTT. Modularity is of great importance. If a new application of the device appears or the actual system needs some changes, like adding a new sensor, it is only need to develop or modify the acquisition module. Maybe redesign the power supply module or the server, but maybe. How did we make this possible? Well, we developed a communication and management protocol over I2C, and it works in this way. The first thing when the system starts is that the main module scans I2C bus and registers all the live I2C directions by asking for some information to the secondary modules. With this information, the main modules makes an agenda. After that, all the modules go to low power mode until the main modules wakes them up for an acquisition. So, with this protocol, make an upgrade of the system is only bring the new module, connect it, and reboot the main module. For this project, we use low-cost and well-known technologies like Arduino, GPRS, SD readers, and I2C as the communication protocol. Non less important, we use open source technology as much as possible. Now let's take a look to the in-file device. As was said before, we have I2C and power supply integrated bus. So all the modules have a 7-pin connector for this. As mentioned, the main module gathers information from the secondary modules, makes a scheduler, and manages the local system. But it's also the only one that has external connection with the server. It sends the acquired data and receives commands from the server, like parameter changes. And of course, there must be the customizing modules and the power supply module. The server, the remote part of the system, the one that allows the customer to have access to the information in real time. All that is needed for basic functionality is an MQTT broker and an MQTT client. We also perform a web server using Influx database suite. Additionally, we test other platforms that have MQTT integrated. As we approach to the end of this presentation, we would like to show you 2 implementations. This equipment was developed for a research group of our university. They need a piece of equipment that can acquire some variables from Beehive to monitor the effect of the use of pesticides and agrochemicals. For that, 2 customizing modules were developed. One that acquired ambient temperature and humidity and the Beehive weight. And the second that acquired 4 audio channels. Those acquired the inside sound of the colony. On this implementation, the power supply module has solar panel with a battery and can supply power for a week without sunlight. This module also reports the internal module temperature. That is the box of the main module. The second implementation was for another research group. This group had already developed an in-situ laboratory module and were using it locally for debugging. When they finished the debugging, we made minor changes and adapted to the platform as 2 customizing modules. One acquires nitrogen and phosphorus, and the other acquires pH level. For this particular case, the power supply module was just a battery. That was because they have to go once a week for reactive changes, and at that moment, the battery is replaced. In conclusion, the design platform makes the development of acquisition systems easier, faster, and more robust. We successfully solved 2 different problems. One, which involved the development from scratch, and the other as an adaptation of customized modules. We are certain that this solution can be adaptable for complex implementation. 3 important aspects of this platform are a friendly user interface. It ensures data transmission in rural areas with weak connectivity and the use of affordable open source technology. Finally, this is our contact information. Please feel free to contact us with questions or feedback about our presentation and the publication itself. Once again, thank you very much for your participation.